Okay, up until now, we've been given an equation and asked to come up with the graph. These two problems, we're going to do the opposite. I've given you some graphs, and we're going to come up with the equation. For this one, we're going to come up with an equation in this form, so it's a transformation of sine. For the second one, we'll come up with a function in this form, so that it's a transformation of cosine. In both versions, though, whether it's a transformation of sine and cosine, the A, B, C, and D all pretty much play the same basic role. So let's see if we can take a look at what information we get from each of those. Notice A in both cases is the number that I'm multiplying the trig function by. That's what's going to perform the stretch or the shrink depending on how big A is. So I know that the amplitude is going to be the absolute value of A. Amplitude is never negative, and I don't know whether A is going to be positive or negative here. So very important that I include that absolute value there. Okay. If I move to B, B is the number that I'm multiplying by, but it's the number that I'm multiplying x by. So I know that the period is the original period of 2 pi divided by the absolute value of that B. Period is also never negative. Now, your textbook doesn't actually give you any examples where B is a negative number, so it's always going to be positive. But in theory, it could be negative, so it's a good idea to write in that absolute value there. Okay. All right, if we look at what C does, that's the number that we're adding after we've done the sine, or after, in this case, we've done the cosine. So that's going to tell me about the vertical shift. So the vertical shift is going to be the absolute value of C units. And since that's a vertical one, that's intuitive. That's up if C is positive and down if C is negative. Okay. And then the D, well, that's the number that, notice we're subtracting it there. But what we're adding or subtracting to x is going to be our phase shift. That's going to be our horizontal shift. We're going to shift things to the absolute value of D units, and that negative sign sort of takes care of the fact that it's counterintuitive. It's going to be, if we're subtracting a positive number, then we'd be moving things to the left. So this will be left. I'm sorry, if we're subtracting a positive number, my bad, we'll be moving things to the right if D is positive, and we'll be moving things to the left if D is negative. In our example before, we were adding a number. If you add a positive, that's equivalent to subtracting a negative. So subtracting a negative number is like adding a positive, and that moves things to the left. Okay, so I sort of want to use this information to try to figure out these two formulas. What I'm going to suggest is, if you feel up to it, pause the video and try this first one. Then turn it back on and work through it with me, see how you did. If you don't feel comfortable with that and you want to just warm up by working through the first one with me, that's totally fine. After we do this one, I'm going to suggest that everybody pause the video and try that second one. Okay, so let's look here. If I want to figure out what A is, okay. Well, first of all, since we're looking at a sine graph, looks to me like we're doing one period as we go from 0 to 8. Okay, so, and that's starting middle, going up to high. Doesn't look like we flipped it over. We start at a middle value and go up. So A is going to be positive. And if the amplitude is the absolute value of A, well, I noticed that the high value is 6. The middle value wasn't explicitly marked, but the low value is 0. So the middle value has to be halfway in between, so that's 3. So the amplitude is this vertical distance between high and middle. 6 minus 3 is going to be 3. So A is going to be 3. Okay. Now, we said the period, it looks like we start here, we go through one cycle over the interval from 0 to 8. So that makes the period 8. So if 2 pi over B is equal to 8, and I'm going to suppose that we can use a positive B here. Okay. You can always choose to do that if you want to. You can always pick a positive B. So that means 2 pi is equal to 8b, To solve for b, I'll divide both sides by 8. So b is 2 pi over 8, or pi over 4. Excellent. Now c, that was the vertical shift. So I want to see how much I've shifted things up or down. Looks like I've moved things up. And I want to focus on this middle value. The middle value would have normally for sine been here at 0. It's now at 3. So it looks like we've moved things up 3. If we move things up 3, that means c is a positive 3. Okay. And in this case, it looks like we didn't actually do a horizontal shift at all, because we're starting here at 0. So I'm going to say my d is just 0. So then I can put all the pieces together. So y is equal to c, we said was 3, plus a, we said was 3, times sine of b, we said was pi over 4, times x minus d, and we said d was 0, so just times x. Didn't need all that space. Pi over 4 times x. Okay. Excellent. So we were able to take information from the graph and work backwards to get a formula for the function. Okay. So pause the video. See how you do on this second one. Okay. I'm going to erase the board. You guys pause the video, give it a try, come back, and we'll do the second one together. Okay, so I'm looking at this one as a transformation of the cosine graph. So I know I want cosine to start at either a high value or if I flipped it, a low value. Looks like I can actually start here at 0. That would be at a low value, the point 0, 2. And we come back to a low value at time 2 pi over 3. So I'm going to view that as my one period that we're looking at. Okay. So it looks like the low value is 2. The high value up here is 6. That would put the middle value at 4. Okay. So the amplitude is that vertical distance, which is 2. Want to be careful here, though, because a is going to be negative 2. Because I'm stretching by a factor of 2, but because we're starting at a low value rather than a high value, I'm also doing a vertical flip. Okay. Now, for b, it does look like I can start right here at 0. So the period is just 2 pi over 3 minus 0, which is 2 pi over 3. Wrote out that subtraction problem to remind you that the period is not necessarily the ending point. It's the distance between the beginning point and the ending point. Okay. But I know that the period, 2 pi over 3, is supposed to be 2 pi over b. Well, that tells me that b's got to be 3. That's kind of nice. I can solve that one by inspection. Okay. Then c, that's going to be the vertical shift. And again, I want to focus on the middle value. It's tempting to say, oh, I shifted things up 2, but I didn't. I shifted things up 4, because the middle value on sine and cosine is usually at 0. So if we move things up 4, that's going to mean that c is equal to 4. And then it looks like, once again, we didn't actually do a horizontal shift because we were able to say we were starting here at 0. So we get d is equal to 0. You could see a similar question where I just asked for something of this form and there wasn't even a d here. Here we just had to figure out that the d wasn't really necessary. So I can say y is equal to, c is 4, plus a was negative 2, so I'll write that as minus 2, times cosine of b was 3 times x, and I wasn't subtracting anything from it. So kind of a fun puzzle. Good thing to do if you have a problem like this on a quiz or an exam or in the homework is figure this out, and then you can sort of come back to it and say, if I were graphing that, what would I do? Or you can just check some of your points. For example, the point 0, 2 is on this graph. Well, if I plug in 0, I'm going to get cosine of 0 is 1. 1 times 2 is 2, so this would become 4 minus 2. Yes, that's 2. I can double check that that point works. And if I wanted to, I could plug in other points. Pi over 3 gives me a value of 6. Pi over 3 seems like it's messy to plug in, but notice I'm multiplying by 3. 3 times pi over 3 is just pi. Cosine of pi would be negative 1. Negative 2 times negative 1 is positive 2, and 4 plus 2 would give me 6. So I can always sort of double check my work, because it's very easy to make a careless mistake with this sort of problem, but it is kind of a fun puzzle problem to do. All right, and with that, this is the last video for section 4.2. So we finished up that section, and when we come back, we'll start with section 4.3.